All right, 1.2, still going. Here's kind of part two of everything. A little recap from part one. We're talking about which function here has a discontinuity at x equals 2 or is discontinuous at x equals 2. Well, that first one has no discontinuity. It's continuous. The second one, though, if you look really closely, my notes are a little, it's hard to see that, but up there in that corner at about x equals 2, there's a hole there. That's the one we're talking about. There's a removable discontinuity. We call it a hole at x equals 2. Next in line, let's talk about increasing and decreasing and constant functions. We've briefly mentioned this already before, but here's a formal definition. Increasing if, between 2 points on an interval, there's a positive change as x increases. And then here's decreasing if you're going between 2 points, there's a positive change, or negative change in f of x as you go from one x point to the next in a positive direction. So you go positive in the x direction, or x is increased positively, and the function goes down. All these, whenever you're reading a function, you always read left to right. You move from left to right along the x-axis. If it's going uphill, that's increasing. If it's going downhill, that's decreasing. If you move from left to right across the function and it's staying plateaued, that's called that's a constant portion of your function. So if I'm dealing with increasing, you've got a nice little one in the first part here. This one is, you guys have seen this, like something like maybe a third root or a fifth root, looks something like that, maybe a little bit shifted. That's increasing. Decreasing, the second one always going downhill. Constant would be something that's flat. So those are just descriptors of kind of the behavior of the graph as far as increasing, decreasing, constant. Sometimes you get these piecewise functions that have each, decreasing here on the left. If you move over to the middle here, it's constant, and then it's increasing on the other side where it's going uphill. So you always move from left to right, and we describe increasing, decreasing, and constant as x intervals. These are all intervals of x that we're looking at here. So it's always in terms of x. Ooh, bad typing there. So in terms of x, that's key to making this work. And that can be kind of confusing sometimes when you're talking about increasing and decreasing and so on. 6 down at the bottom here. Here's an example of a piecewise function. And what you'll see is it's a pretty cool looking function, and we should probably get in some detail. But for a certain range, domain of x values, this function you see here on the left, these two subtracted absolute values, behave like f of x equals -5, a nice constant flat graph. Anywhere left of -3, it's constant. Let's do interval notation, by the way, just to be sure. Negative infinity to 3. That two subtracted absolute values looks like a flat graph hovering at -5 below the x-axis. Once you get to -3, though, it changes to being a line. You notice that line with a slope of 2 and a y-intercept of 1 going uphill. So from -3 to 2, you're just going to see this little chunk of line. By the way, notice that when it has an equal sign in the top interval up here, less than or equal to -3, you'll notice the bracket. These two in the middle section are just less than symbols, so we have 2 parentheses showing here. And finally, the last one, the graph behaves as though it's at a constant height of 5. It's plateaued at 5 from 2 to infinity, and that is including 2 because of the equal sign there. The last couple pieces of this, let's get back up here. We have 2 missing functions in number 7, so you can go ahead and fill these in, pause, write these in, do whatever you need to do. But we're interested in increasing and decreasing behavior. These are known functions. So a is a parabola shifted left 2. So if I want to know about increase and decrease, let's start with increase. Uphill, the graph goes uphill from, that's a typo in there, whoops, that's not 0, that's from -2 to infinity. You'll notice from right here, this is x equals -2 to infinity, that graph is going uphill. In decreasing, how much you want to bet there's a typo in there? Yeah, same one. So that's -2 again. So those are the places where it's decreasing from -infinity to -2. You can hardly see my negative, can you? Let's see if I can get it in there. Yeah, that looks good. And then from -2 to infinity, it's increasing. Okay, so that's the uphill, downhill, read left to right. If I go to part B, this graph, you'll notice by looking at the denominator, -1 and 1 are values that wouldn't work, so they're asymptotes there, vertical asymptotes. I've written them in red. The rest of the function looks like this. I'll fix that middle section. It's a little messy here in just a second. Increasing, if we look at it on the very far left there, -infinity to -1, it's going uphill. I did not include -1. And then also from let's see what's another place it's increasing. -1 to 0, not including -1. So that parenthesis here, maybe I should do that in a different color. Yeah, let's back that up just a tad bit. Let's go purple. This parenthesis here means I'm approaching -1 from the left, not quite touching it. And this parenthesis here says I'm starting from -1, not quite touching it, going up to 0. That graph is going uphill. Again, increasing describes an uphill. And then the decreasing sections are from 0 to 1 and from 1 to infinity. I might highlight these a little bit, so let's use different highlighters. We got -infinity to -1, that chunk right there. Let's pick a different color. Let's go orange here. Then this little chunk, -1 to 0, right there. Let's highlighted those to match them up. Let's go green on the next one. There's some decrease from 0 to 1. That's these two pieces. So, and then finally, I don't know, I'm going to go purple at the end. Go highlight that little dude. That's another section of decreasing. So I want to color code those so you can see the intervals and then also the behavior on the graph itself. That's it. That's enough to get us through most of 1.2. There'll be more, obviously, but that's a nice head start. See you soon.